In this class, you are going to learn finding normal to a curved surface, that is concave mirror and convex mirror, focal point and focal length of concave mirror, and ray diagrams of concave mirror and convex mirror. Okay, these we are going to learn in this class. First, let us find out the normal. Let us find out the normal to a curved surface. For the simple case, normal case, here this is a plane mirror. For this plane mirror, we can find the normal very easily. It is very easy to find the normal to a plane mirror. That is, if you draw a line here or line here and a line here, these are all normals. It is a normal at this point. It is a normal at this point. It is a normal at this point. Just like this, we can find normals to a plane surface easily. But how can we find the normal to a curved surface? Let us take the curved surface, that is concave mirror. So this is a concave mirror. It is non-reflecting side or silvered side. So in this manner we have to represent the silvering. Just these lines. Okay, this is polished surface. It is reflecting surface. It is non-reflecting surface. Then how can we find out the normals for this? How can we find out normals and how can we draw the normals for this concave mirror? So let us take this one. It is the plane mirror. Just we think that it is a plane mirror and these pins are normals at this point. These pins are normals at this point. So it is just like this, plane mirror and normals. And let us take the same thing in case of curved mirror. And how can we make this one into curved mirror? Just if you bend like this. If you bend like this, how does it represent now? What does it represent now? It represents a curved mirror. It represents a curved mirror. This is a normal at this point. This is a normal at this point. That means each and every pin represents the normal at that particular point. Yes. So how these pins are looking like? These pins are looking like that. They are going to converge at a point. They are going to converge at a point. Yes. What is that point? That point will be the center of curvature. That point will be the center of curvature or center of the sphere from which this part is obtained. Right. So here, how does it look like? So to draw the normal, to draw the normals for a concave mirror, what we have to represent first? We have to represent the center of curvature. We have to represent the center of this curve. Yes, if you take this as a total sphere, yes, so this is total sphere, right? From this sphere itself, this part is obtained. Yes, if you extend this one, it will be a sphere. Yes, it will be a sphere in this manner, right? It will have a center. It will have a center, right? So here, if it is this one, all these normals are tended to converge at a point. Tended to converge at a point. That means from the center of the sphere to every point or any point on the mirror, they represent normals. Is it clear now? Right. So this is the center of the sphere. Yes, from the center of the sphere to any point on the mirror, from center to any point, they represent normals. Just like from the rules of from the geometry of circles, if it is a circle, yes, it has a center. It has a center. So this is the part we have taken. Yes. So this is the one radius. Yes. And it is the diameter, we can say. Yes. So this, if you draw a tangent at this part, if you draw a tangent, so with this tangent, this one makes a 90 degrees angle. That means whatever the part you take, whatever the point you take on the circle, whatever the point you take on a circle, to that point, whatever the line you draw, that acts as a normal, that makes 90 degrees of angle with that tangent. Right? In the same manner, from the center of curvature of this mirror to any point on the mirror, if you draw, that acts as a normal. Right? So that is in case of a concave mirror. Let us take the convex mirror. and silvering on this side. On concave side it is silvered, so convex side is the reflecting surface. So here let us see. So its center of curvature will be this side, right? Its center of curvature will be this side because it is a circle now. It is a total sphere. It is a total sphere, just like this. It is a total sphere, so its center of curvature will be on this side. So from this center to any point on the mirror, if you draw a line, if you draw an imaginary line from the center to any point on this mirror, those lines act as normals. Those lines act as normals for this mirror. So how these are looking like? These, all the normals are looking like that they are divergent from that mirror, or they are originating from the center of this curve, right? Just like in this manner. Yes, let us take this one and let's bend it in the manner of a concave mirror, just like this. Like this, all the normals are tend to diverge from the mirror, right? So this is how we can find out the normals for spherical mirrors. From the center of the curvature to any point on the mirror, if you draw a line, so that line becomes normal at that point or for that mirror.